Hi everybody. In this first video of our class, Computational Thinking, we're going to see what it means to answer a question computationally. The particular question we're going to address is, does the media have a political bias? The subject of this presentation is answering questions computationally. And I'd first of all like to acknowledge that these slides are largely based on slides that Stephen Bronner at Brown University developed as part of Brown's CS3 course, which is in fact the inspiration for this course. We're going to look at the question of political media bias. Does the media have a political bias? And the question begins with a claim made by the author of the book Bias, Bernard Goldberg. The book was published in 2001. Goldberg says, "When I came to CBS in New York in 1981, I noticed that we pointedly identified conservatives as conservatives, for example, but for some crazy reason we didn't bother to identify liberals as liberals. This blindness, this failure to see liberals as anything but middle-of-the-road moderates, happens all the time on network television. In the world of Jennings and Brokaws and Rathers, conservatives are out of the mainstream and have to be identified. Liberals, on the other hand, are the mainstream and don't have to be identified." Jeffrey Nunberg, a political scientist at Stanford University at the time, in an interview on Fresh Air, said that Bernard Goldberg is hardly the first person to claim that the media have a liberal bias, and his bias is far from the best written or best argued book to try to make that point. Even so, it has climbed to the top of the New York Times bestseller list, maybe because Goldberg is himself a CBS insider with lots of tell-all tidbits to offer about the likes of Dan Rather and Bob Schieffer. For the most part, Goldberg's book is a farrago of anecdotes, hearsay, and unsupported generalizations. But at one point, he strays into territory that can actually be put to a test. That's when he claims that the media pointedly identify conservative politicians as conservatives, but rarely use the word liberal to describe liberals. So Nunberg says, among all the claims that Goldberg makes in Bias, there is one thing he says that we can actually put to a test. One claim he makes that we can determine, is it true or false? And that's where he says that when the media refers to conservative politicians, it points out that they are conservative. But when they refer to liberal politicians, it leaves off the label liberal. With the implication is that liberals don't need to be labeled because they're the mainstream, but conservatives do. And that seems like something that we can test. We can test. When the media refers to a conservative politician, do they label them conservative? When they refer to a liberal politician, do they label them liberal? So the first step in solving a problem computationally is to define the question with precise terms that can be proved true or false. The second is to select a relevant data source. The media then was a little simpler than it is now. Now we have many more media sources, but it doesn't matter. We need to select the relevant data source. Then we define a method that, using the data, would definitively answer the question. Then we implement the method using some programming language, some computational tools. We evaluate and analyze the results, and then we communicate our results. So this is what it means to solve a problem computationally. And the first part, defining the question, is critical. So Instead of asking, is the media biased toward liberals, we can ask, are liberal politicians identified as liberals more or less often than conservatives are identified as conservatives in major newspapers? And that last qualification, in major newspapers, is pretty important. And it relates to, why did Nunberg select major newspapers? It relates to how hard it is to analyze the different data sources we have available to us. So we have a lot of different forms of media. We have TV, video, we have audio, we have images, we have web pages, we have text, and then we have formatted data, tabular data. And video is the hardest. It's hard to analyze what's going on in the TV video segment. It's a little easier if we can transcribe the TV, the audio into text. That's not that easy. Then we have audio, which also needs to be transcribed if it's verbal. Images are difficult, but text from newspaper articles is easy, as long as we don't have to deal with newspaper layout and organization. That makes it more complicated. So the layout is something we have to deal with if we were scraping text off web pages, text off online newspapers. And I had a student do that, a couple of students who did that. It was very difficult, but it was very rewarding. Very interesting projects. I'll tell you about them in class. So this course is, we're going to work with tabular data, the so-called pre-formatted data, and text data sources. And this is why Nunberg chose to work with text, major newspapers. It's much easier to deal with. And there's plenty of it, so it seems like a fair, it's still it doesn't limit the scope of the question, or the scope of the investigation. So he identified major newspapers as his source. We'll look at that. How do we avoid, once we've selected that data set, how do we measure labeling bias in this data set? We need a technique for that. And what we mean by labeling bias here is the claim that Goldberg made, that conservatives are labeled as conservatives, but liberals are not labeled as liberals in the media. So that's labeling bias. How do we avoid introducing our own bias? By the selection of the data sources. So unless we examine all newspapers, we have to make some selection of newspapers to look at. How do we avoid bias? How do we avoid biasing our results? How do we avoid introducing our own bias into our results? By what newspapers we select to pull data from, to pull text from. The way Nunberg did it is, there is a service called the dialogue service. It's a text, it's a service that, among others, gathers the full text of all the stories in the newspapers that it indexes. So indexes meaning collects the full text and then organizes indexes of it, of that text. And it has a particular database called Papers MJ, MJ for major. Major meaning it has a certain amount of circulation. So Nunberg, to avoid his own selection bias, he did not select the newspapers himself. He used the Papers MJ database and allowed them to select and made no selection. It's just whatever newspaper is indexed there, those are the newspapers he used as his data source. And so you can see they include the Denver Post, the New York Times, Phoenix Gazette, St. Louis Post-Dispatch, Detroit Free Press, Boston Globe, Philadelphia Inquirer, and so on. And then his technique for measuring label bias, he took the question, are liberal politicians identified as liberals more often than conservatives are identified as conservatives in major newspapers? So we've answered what in major newspapers means. But what does it mean identified as liberals? How do we measure that? How do we measure these things? So Nunberg's method was to, first of all, choose a representative set of politicians from each side. So there's not the question of are some politicians conservative and are some politicians liberals. He chose a set of politicians from each side that he believed would be agreed by all. These are conservatives, these are liberals. Then he looks for mentions of politicians in the data set. So he goes through, for a particular time period, I don't know what it was. I have to look at that reference down in the bottom there. Looks for mentions of politicians in the data set. And then for every mention of a politician, he looks at 7 words before the mention and 7 words after the mention of the politician's name. So 14 words, 7 words before and 7 words after. And he computes the fraction of times these words, the words around the name of the politician contain the politician's appropriate label. So we know what the politician's label is. If we find that label, we count it. And then we divide we compute the fraction of times that the name contained, the words around the name contained the label, divided by the by the number of times it didn't. So if we would expect a large fraction for politicians who were frequently labeled and small fraction for politicians who were not frequently labeled. So now we know the data sources that Nunberg is using. How is he measuring his label bias? So the particular question he's answering is, are liberal politicians identified as liberals more often than conservatives are identified as conservatives in major newspapers? How is he doing that computationally? The first thing he does is he chose a representative set of politicians from each side. So he chose a handful of politicians that everybody would agree are conservatives, and a handful of politicians that everybody would agree are liberal. Then he finds mentions of politicians in the data set. So, and then when he finds a mention of the politician in the data set, so he's scanning newspaper articles. The data set here, remember, is the full text of every newspaper article in every major newspaper every day. And I can't remember the time period he used. So whenever he found a mention of a politician in the data set, that is in some newspaper article, he looked 7 words before the name and 7 words after the name. So that's a total of 14 words. 7 words before, 7 words after. And then he looked for the label in those 14 words. And if he found the label, he counted it. And then when he had gone through the whole data set, he divided the number of times he found the label over the number of times he found the name. So it would be a fraction between 0 and 1. It would be 1 if every time he found the name, he found the label. It would be 0 if every time he found the name, he never found the label. Okay, so for each politician, he would compute that fraction. So if he had 10 politicians, he'd end up with 10 fractions. These are the politicians he chose to follow. Liberal politicians: Barbara Boxer, Paul Wellstone, Tom Harkin, Ted Kennedy, Barney Frank. Conservative politicians: Jesse Helms, Tom DeLay, John Ashcroft, Dick Armey, Trent Lott. He was hoping to not introduce bias. I don't know how you guarantee that, but it's certainly possible to introduce bias in choosing people here. If you chose middle-of-the-road politicians, but you called them liberals, then that wouldn't be fair. So he tried to choose politicians that everybody would agree, yep, those are liberals, yep, those are conservatives. Then he looked at words around a politician's name. It's not 100% accurate. Nunberg claims 85% accuracy, and so we'll look at that claim. But so let's look at some examples. Which of these would be correctly categorized by the method? And now it's gone too far, said John Ziegler, a conservative radio host. Yep, that would work. That would identify John Ziegler as conservative. In the quote, when David Brooks complains that conservative opinion meisters began to value politics over everyone else. So he finds the label conservative next to the name David Brooks. Is that text labeling David Brooks as conservative? It is not. So his his technique would fail in that example. That would be a false positive. Mr. Obama, according to the system, rates as being slightly more conservative than Jimmy Carter. Okay, so what's the problem there? Let's count the words around Obama. Between Obama and the label conservative. 1, 2, 3, 4, 5, 6, 7, 8. More than 7. And yet, conservative is applying to Obama, not to Carter. But it would label Carter as conservative, even though that label is not about Jimmy Carter. It's about Mr. Obama. So it's not 100% accurate. Nunberg realizes that, but he claims 85%. What would be the basis of that claim? Typically, the way you do that is you test it by sampling. You sample your data, and you look at look at a certain subset of the data. You look at all the times your algorithm identified someone as conservative, and then you would read the text and make a human decision based, did it work or not? And so then you keep track. all that you, let's say you do 100 samples, and if you found that your technique was correct, 85 out of those 100 times, you would say that you have 85% accuracy. You look at 80, you look at 100 mentions of a politician's name, and then you look at what decision did you make on that mention. Were they identified but you missed it? Did you misidentify? Did you misidentify the labeling? Anyway, so Nunberg apparently did that kind of sample and claims that his method is 85% accurate. So that'd be one thing that we would want to, if you wanted to look more closely at this, you would want to check his technique for measuring his own accuracy. Let's look at Nunberg's results. He has, at the top of his table, he has the liberal legislators he selected to look at. At the bottom of the table, he lists the conservative legislators he elected to look at. In the second column of numbers, he has the percentage within 7 words before, 7 words after of the relevant label, how many times each politician was labeled as liberal or conservative. So we have in these major newspapers. So again, he looked at every article in every day of every major newspaper in the paper's MJ database. So Paul Wellstone is identified as liberal 10.9% of the time, whereas Barney Frank is 4.7% of the time identified as a liberal politician. Tom Harkin is identified 3.7% of the time as a liberal. Looking at the conservatives, Jesse Helms is labeled as a conservative, 9.1%. Of all the times Jesse Helms is mentioned in an article in that data set, 9.1% of the time he is labeled as a conservative. Whereas Trent Lott is down at the bottom row there, only labeled 1.4% of the times as a conservative. The average percentage for liberals is 4.8% in all papers. The average percentage for conservatives is 3.6%. So Nunberg's findings refute Goldberg's claim that conservative politicians are labeled as conservative, whereas liberal politicians are not labeled as liberals. At least in the newspaper, in the print media, and in particular in the newspaper segment of the print media. So did Nunberg, so he refuted Goldberg's claim partially. Goldberg didn't specify what media. Did Nunberg answer the question, does the media have a political bias? Not quite. He just answered a particular question. But he called into question an assertion of someone who does claim the media has political bias, made a specific testable claim. Nunberg tested that claim, found it to be false within a certain subset, an important subset of the media. So this, I find this, these results are very interesting. His technique is very interesting. It's a very good demonstration of computational thinking. it's at the same time kind of troubling. It's on the one hand comforting to think that we can test claims, um, but it also shows you just how easy it is for someone to make a claim and to persuade others of the claim, and how hard it is to actually test the claim. All the work that Nunberg did to answer a fairly narrow question. But it's worthwhile doing that work. It's worthwhile doing the work. Data doesn't lie. Nunberg was very careful to collect his data. He was careful and transparent with his technique, and the results speak for themselves. So this is just very important work to do all over the place. We are going to apply this same kind of process. We're going to focus on the technique, in particular on the computational methods we use to apply a technique, because that's what this class is about, teaching you one aspect of this practice of answering questions computationally, which is the computational aspect, the programming aspect. It's not the whole thing, but it's an important part of it. We are going to spend time answering a particular question: what is the reading level of a given book? We're going to look at how do lyrics of songs of the 60s differ from lyrics of today's songs? Those two questions we'll look at in this class. The question, are any of these freckles on a medical image precancerous? That's a question we're answering in a group we have called MLab at Manhattanville, Machine Learning Laboratory. We're analyzing images from an area dermatologist who has years and years of data. And it's proving to be difficult, but it's a tremendous learning experience. I've had a student look at, take the question, is this joke funny? That's a tough one, but he actually did quite a bit better than picking an answer at random, given a joke. Another question, kind of related to this political media bias question, is given someone's comment on a news article, what are that person's political leanings? That's you and I could answer, could take someone's comment. We could identify where that person is on the spectrum of political leanings. For a computer, it's very hard, but he tackled that issue and made some progress. A student of mine. And something I'm particularly interested in, given some students' code, what misunderstandings is this student displaying? If a machine could do that, then the machine could make some more pointed observations about the student's code. So all of these things, and that's something that I can do in a moment. So if I can do it, I should be able to train a computer to do it. So scratching the surface, beginning the journey of how we do this is the subject of this class. And I look forward to seeing you in class.